Okay. So a reminder what probability is. Probability is the percent likelihood that an event is to occur. And remember that our percent will be from 0 to 100% likely. 0% being never going to happen. 100% means it's definitely going to happen. And it can also be written as a fraction. So like 1/6 is really just a probability. Then to get the percent, you do 1 divided by 6. I'm going to do an easier one. For example, 1/2 is really, you type that into your calculator, you get 0.50, so that's 50% likelihood. So you can see it written as a fraction or decimal or percent. Sorry. Okay, so let's go ahead and remember that we were using tree diagrams last time to list out possible outcomes, not probabilities, but possible outcomes so that we could then do probabilities. So everybody, it says draw a tree diagram for rolling a 6-sided dice and flipping a coin. You remember what we're doing is we're just making a picture of what possible outcomes we could get from doing this, actually, in real life. So think about a 6-sided dice. If you roll a dice, you can get a 1, 2, 3, 4, 5, or 6, correct? So that's our first event, and once again, these are independent events because if we do both of these things, they'll have no effect on each other, right? Okay, so what's our possible outcomes for rolling a 6-sided dice? We could get a 1, a 2, we could get a 3, a 4, we could get a 5, or a 6, right? Now that's just one event. Now 2 events, we're flipping a coin. We're just flipping it once, so there should only be 2 events. So we're flipping a coin. So remember, now we're going to branch out to show possible outcomes. So let's say we did roll the dice, we landed on a 1. Now we're flipping our coin. Are we going to land on a heads or a tails? So we're going to land on a heads or tails. So we could get a 1, then a heads. We could get a 1, then a tails. Correct, everybody? Do I need to write those out, or can we just use them like we did last time? Okay, perfect. If we roll a 2 on the dice, the next time we're going to flip a coin, we could get a heads or tails. Let's say we would have rolled a 3 on the dice. When we flip our coin, we'll get a heads or tails. 4, same thing, heads or tails. 5, we rolled a 5. Well, we're going to flip a coin and get a heads or tails. And 6, we rolled a 6, then we flip a coin, we're going to get heads or tails. So this is the possible outcomes and the order in which we could get something. Correct, everybody? So let's count how many possible total outcomes so we could talk probability. Now remember, we don't want to have to actually count, like we can count that and that, that and that, but like let's just count the outside of our tree diagram. Remember that trick I showed you last time? So how many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. Everybody good? All right, so now let's go ahead and answer these probability questions. So I just redrew it out up here. Here we go. So what's the probability of landing on a head? How many times does that happen in this? Out of, we said 12 total. Just gonna box that. So how many times do we get a heads out of 12? 6 times, correct? So our probability of getting a heads is 6 out of 12. That would be the fraction, which is 50%. Type it into your calculator if you need. 6 divided by 12. Everybody good? All right. Now we do need to remember our notation. Now we're asked, what's the probability of even union? That's a U for union. Even union heads. Now, united people, remember the smiley face? Everyone's united, right? If you join, if you're a union, you join together. So, evens get to come. Anytime we get an even number, it gets to come, and anytime we get a heads gets to come. Now remember, I like to use little check marks to count so that I don't double dip. So everybody will watch carefully. Let's make sure I don't mess up. So how many times do we roll an even? So either or gets to come. So how many times do we get an even? 2, correct? Those get to come. Yes. Oh, okay, yeah. Perfect, there you go. So we get an even 3 different times, correct? Now think about it. We actually get even how many outcomes total. We've got to capture the heads and tails, right? Because if we listed them individually, I didn't even think about that until just now. If we listed them individually, we technically get 2 twice, right? A heads and a tails. Does that make sense? So there's actually 1, 2, 3, 4, 5, 6 times that happens. So that accounts for those heads and tails. Okay, so that's 6 times. Here we go. So you're going to write 6. Now united with any heads. Now look. Those heads have already been counted for, correct? So we're not going to double dip. How many other times do we get heads? 1, 2, 3 additional, correct? So we're going to have 6 plus 3. That's how many times we get even or heads. So 6 plus 3 is 9 out of 12 times that happens. So let's write out the decimal. 9 divided by 12 is 0.75, which is 75% likelihood. Okay, now I'm going to hurry and quickly erase my check marks because, like I said, it helps me not double dip. All right, let's answer these next ones now. So it says, what's the probability of even intersect heads? Now, intersection is where they cross, guys. It has to be both at the same time. It has to be even and heads, and that's it. Does everybody understand? Even and heads. So how many times does that happen? Right there, right? Even and heads, even and heads, even and heads. Only 3 times, correct? So you would say 3 out of 12. The intersection is only where they intersect. It has to be even and at the same time heads. Is everybody good with that? 3 divided by 12, oops, 25%. All right, so next one is, okay, it says, probability that we're going to get heads complement. I know we struggled with this last time, so try to think of what heads complement really means. Remember, complement means everything that's not a heads, correct? So heads complement would be tails, correct? So instead, I'm going to write what's the probability of getting a tails. That way, it's just as easy. It's the same thing as heads complement, but it doesn't confuse me so much. So what's the probability of getting tails? 1, 2, 3, 4, 5, 6 times, correct? 6 out of 12, which is 50% likelihood. So don't let compliments throw you off. Just write in what you're really asking. Does that make sense, everybody? Okay, so let's do this one. What's the probability of odds intersects tails complement? So look, the complement is just on the tails. So let's rewrite what this is really asking us to find. The probability of odds intersecting, what is tails complement really? Heads. Does everybody see how I'm doing that? So heads. So we want to know, does odds intersect heads? Now that is only, the intersection's the picky one. It has to be odd and heads. Does everybody understand? So let's find where that happens. Odd and heads once, twice, 3 times. That only happens 3 out of 12 times, which is once again 25%. Now look at the difference in the next one. It says the probability of evens united with heads complement. So let's see here. This one is all of it is the complement. So evens united with heads, this one I will think through by actually going through and figuring out what that probability is, and then we're going to do the opposite. Does that make sense? You see what I'm saying? Because it's evens united with heads complement. That one's a little bit harder to say, well, what is that? Does that make sense, everybody? So let's, yes? Oh, I guess we could. Well, and I'm just trying to think. Maybe I'm just not thinking very good about it. Heads, like, so that's a good question. Why can't we just do tails? And maybe we could think of it. Could we think of it? Let's think about this. So evens united with heads, the complement of that would be odds united with tails. Would it be? Would it be? I'm maybe just not thinking very good. Like maybe I'm thinking, I often think too hard about probability. So let's go with that, and then I'll check it the way I did it, and that's a good way of thinking of it if you can. So odds united with tails, okay? So I'm going to do it my way and then go back and see if that's right. Because I know my way is correct, so let's check it. Because if that's an easier way to think about it. So evens united with heads, I'm going to not do the complement, I'm going to check off that. So evens united with heads was that, right? Okay, evens united with heads, even united with heads, even united with heads. Now that's united, so actually I should be checking off, so all evens should be crossed off, correct? I did the intersection just earlier, right? So I should be doing all evens, so also that gets to come, right? And union means both get to come, sorry, not and, or heads. So now I'm going to check off, isn't this a head that gets to come, this head gets to come, and this head gets to come. So now we want the not that. So So how many did we not check? Oh, I hated that. That scared me. Okay, so everything that's not that, that's what complement means, right? So there was only 1, 2, 3 that were not, right? So we'd say 3 out of 12. So now let's think of it as you were saying, which was 25%. Let's say, okay, so let's pretend we wanted to do odds, united, tails. Yeah, that worked out the same. Way to think of that. Look, odds united with, oh, no, wait, that accounts for these though, right? Because if odds united with tails, that would be all odds get a come, right? So both of those, all of those would get a come, but do you see how then the heads would get a come? Does that make sense? So this one is a little bit hard to try to think of the reverse of. You could, but I almost think like why have to memorize and remember all the flipping? You know what I mean? Because now I'm saying, oh yeah, we intersected, but that's too much to think about. It's almost easier to go through and cross out the yeses and then just do the opposite because complement means everything that's not that answer. Does that make sense? But that was a good question. I'm glad you asked because I didn't know the answer until I tested it. So very good. All right. So what I want you guys to do is either on your paper somewhere or on a whiteboard or whatever, I want you to draw a tree diagram for flipping a coin twice. Now think about it. If you flip a coin twice, those are 2 different events, correct? You'll get a heads or tails, and then after that we'll branch off heads and tails again, correct, everybody? And then at random, what the heck? I swear I put a Twix on there. Oh yeah, and then at random, from a broken vending machine, pulling out a Reese's or a Twix. I'm going to add my Twix back on there. So start your tree diagram for the flipping 2 coins. Now remember, those are not separated. Those are going to be branched out from each other, right? Okay, go for it. Okay, so let's say there's 2 Twixes. A Twix and a Twix. Let's just do 1 Twix so that it's not so big. So you went through and said, okay, I could get a heads, tails, and then on my next flip, I could get a heads, then tails. If I got a tails, I could get a heads, then tails. And let's say I got a heads, heads. When I go to draw out of the machine, I hit a button, I'm either going to get a Reese's, a Reese's, a Reese's, or a Twix. Now, we could write this as 3 Reese's and then Twix, but then we could just add up those, but why not just do this? You know what I mean? It took us an extra second, and we will make sure to not mess up. So that'll be a Reese's, a Twix, a Reese's, a Twix, a Reese's, a Twix, or 3 Reese's, a Twix. Okay, so you guys have your tree diagrams drawn. So how many total possible outcomes? 16, right? Count the edges of the trees. Can you all see that there's 16 total? Okay, so I'm going to write that. 16 total possible. Okay, so now let's answer the questions on the probability. I'm going to do like 1 or 2 of you, and then I'm going to let you just think you can do it. So what's the probability of getting a Reese's united with tails? So united means both answers get a come. So anytime you get a Reese's, you need to include that in our answer. So how many times, count how many times we got the answer Reese's. 12, okay? Now count, not including the tails you've already counted. How many more times do we get a tails besides the Reese's we've already got? You should be looking at your tree diagram and counting. Again, now that I can see a tree diagram. How many times did we get a Reese's or a tails? So you said Reese's was 3, 6, 9, 12, correct? That is true. Now, we've already accounted for that line, that line, that line. Okay, so how many, so that was check marked here. Check, 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 check. So how many more times united means tails get to come to? 1, 2, 3, 4, correct? It just said any tails, right? United with tails? Yes. Oh, those are Twixes. Sorry guys, I'm not thinking very good. Okay, so tails. So let's look here. We've already, okay, so heads, oh, Twix, right? Sorry, I should have wrote out Twix because that is super confusing. Heads, Twix, no. Heads, tails, Twix. Oh my heck, no wonder I was confused. Twix, okay. So heads, tails, oh, so there's another one, correct? And then down here, heads, we've already accounted for, oh look, tails, oh, tails, right? Tails, is that right? So tails, heads, Twix, that one gets to come, right? So you add another one, sorry. And then tails, Twix. Okay, so that one gets to come. So it's 3, wasn't it? Did I make mistakes anywhere? There's 15. Perfect. So we had 15 out of 16 times. Oh man. Oh, that was this one. 15 out of 16. All right. Wow, I made that hard. All right. So do you guys think you can answer these ones, huh? Okay, let's see if you can without my help. All right. Those were pretty hard. So anyways, let's just move on to this next piece here. So we're going to remember now we're to two-way tables, which is what we did last time. So here we go. Let's answer this question. So from the class, you have to vote even if you don't like either. If you had to force yourself to eat a Twix, Snickers, or Reese's, what would you pick? So first of all, how many people, so how many girls are in this room? Let's include me. 1, 2, 3, 4, correct? 4 girls. Okay, so there's 4 girls. How many of you would choose Twix? You have to vote. 0. How many of you would choose Snickers? 1. So you're all the rest of you are picking Reese's? Okay. And then, so you 2, 3 of us pick Reese's. Okay. So then how many total? 4 girls. Everybody good with that? Now, boys, there's 3 boys. How many of you choose Twix? 1. Okay. Snickers. 1. Reese's. Perfect. 3 boys. So then how many chose Twix total? 1. How many chose Snickers total? 2. So remember, these are the totals. I'm going to maybe color them because sometimes totals, I honestly, when I usually, so we shared worksheets, a lot of times I don't even put totals because sometimes it confuses students, if that makes sense. I usually just look up here. Does that make sense? But anyways, how many people chose Reese's total? 4. And then how many girls total? 4. Boys total? 3. And then the grand total in the class would be this bottom corner. There's 1, 2, 3, 4, 5, 6, 7. 7. Okay, perfect. So I always just like to go off to the side and say there's a total of 7. Sometimes if this part confuses you, just count 1, 2, 3, 4, 5, 6, 7. Does that make sense? I a lot of times think people get confused by this. All right, so let's answer the probability that there are boys united with Snickers. Boy united means both get to come. Boys get to come. Anyone who likes Snickers get to come. Everybody's welcome, right? We're uniting them. So how many boys are there? 3 boys. 3 united with Snickers lovers. Oh, but we already counted for that one, right? So 1 more. Everybody see. Plus 1, so that's 4 out of 12. 7. 4 out of 7. All right, let's do girls intersect Reese's. Now this is intersection. It has to be girls that like Reese's. That's it, that's it, that's it. Girls that like Reese's. So girls that like Reese's was, girls that like Reese's is 3 out of 7. Everybody feeling good about this? All right, girls complement means that we're looking at boys, and it's intersecting Twix. Now, intersection is picky. It's only the boys that like Twix. That's it. Boys that like Twix, there was only 1. 1 out of 7. Just a reminder, boys united with Snickers complement. Now, this is the hardest one, I think, with all of it. You know what I mean? Like we just practiced. So let's go through and do boys united with Snickers, check marks, and then do everything that we didn't check off. So boys united with Snickers. So all boys get to come. United with Snickers get to come. So how many are not that? 0 plus 3. Does everybody see how that's not too bad? 3 out of 7. All right. Sweet. We get it. So go to your worksheet. Number 15. On the back, it'll be last time's worksheet. So the one from last time. So it says in a class of 50 students, 18 are taking chorus, 26 are taking band, 2 are taking both chorus and band. You've got to go through and put that in the correct spot on our area model here. So let's think about this. So they either like chorus or don't like chorus, right? Look at the area thing. They either like band or don't like band. Everybody good? Or not like, but are in band. Okay. So it says in a class of 50 students, so there's a total of 50. I'm going to put the 50, the very bottom right corner is going to be your total. All right, it says 18 are taking chorus, and they didn't say anything about band. So they're just chorus. Everybody look. Chorus, but no band, right? 18 are just taking chorus. And then it says 26 are taking band. So that they said nothing about chorus. So you'd go to band but no chorus. That was 26. Everybody see, you're going to have to be able to do that on your test. Fill it in. And then it says 2 are taking both chorus and band. So the chorus intersects band. They're taking both. There's 2 of them. So now it assumes that you can use logical thinking to fill out the rest. So let's go through and do our totals and make some assumptions here. So how many total here? How many took chorus total? 20. Now we can't do the no chorus total because we don't know this, correct? Well, couldn't we figure that out since we know there's 50 students total? So you'll take 50, subtract 18, subtract 2, subtract 26. Will that give us the leftover people? What is it? 4. Okay, perfect. And then we can do our total here. So that's 30. And so then 18 plus 4, 18, 19, 20, 21, 22 here. And then 26 plus 2 is 28. Now, once again, if the totals, like I usually don't even really look at those very much because they throw me off personally. Like I said, probability, let's not make it harder than it needs to be, but whatever. Here we go. So now can't you answer the questions below? We practiced all that with the all the at Snickers and all that. Okay, go. I got that one. So let's think about 17. Chorus complement. Let's do it the one way that we've done it before with this one. The chorus complement, means not chorus, correct? So let's check off chorus. So isn't this one included in chorus? And this one. So everything in that would be 26 plus 4. Does that help? All right, so everybody look up here. This is on the worksheet. If you go to, gotta remember. Oh, it's just the very top problem. Here we go. So let's answer these questions. A union B. So everybody, D is your sample space. Look up there. So sample space is the all possible outcomes, basically. A is a subset. Remember, subset means just a smaller piece taken from the sample space. So it's basically they took and cut it and pulled it down. Does everybody see? Now you can put it back, and then we're making a different subset, and they took and cut from here to here and dropped it down into subset B. They put it back. You get what I'm saying? These are just subsets, remember? And then C, they took 4 and 8, and they made another subset. So subsets are just smaller pieces of the sample space. So let's write out our outcomes. This isn't probability. We're listing out the outcomes for A united with B. Everybody's welcome in A united with B. Now we can't double dip because look in the sample space. Those numbers are only listed once, correct? So we won't double dip. A united with B. 1, 2, 3, 5, 7. Now let's go on to B. 2 has already been listed, correct? 4, nope, I've got to add 4. 6, nope, we got to add 6 and 8. There's A united with B. It's like uniting them in together. Let's do A united with C. So everybody's welcome if they're in A or C. So 1, 2, 3, 5, 7. From A, then look at C, 4. Well, that wasn't in A already. And 8, so we got to put that in there. They're both, it's like uniting them together. Yes. Yeah, because union means everybody's welcome. So, yeah, but we'd only list it once. Does that make sense? Good question. All right, let's do A intersect B. A intersect B. Now, this is the picky one. This is like the intersection where they're the same and only where they are the exact same. So in A, there's a 1. Is there a 1 in B? No. There's a 2. Is there a 2 in B? So that is an intersection, so it gets to come. There is a 3, not a 3. There's a 5, not a 5, a 7, and then that's it, right? So the only intersection, they were only the same at 2. A intersects C. 1, Any ones? Nope. 2. Any 2s? Nope. 3. Any 3s? Nope. 5. Any 5s? Nope. 7. And nope. No, nothing. So what it's called is the empty set. Just like a circle with a line drawn through it. Or you could literally go like this and draw an empty set. Nothing. Does everybody see that? Literally, I'll accept either answer, both in probability acceptable. All right, so that little squiggly just means complement, just like if we had a complement, like this. A complement. It's so interesting how they write things. Every book writes things differently and stuff. So squiggly line A means everything that's not in A. So everybody, look in A. You won't use B or C. We're looking at the sample space. So in A, there's a 1. So I'm going to go to the sample space. There's a 1, there's a 2, a 3, a 4, 5, sorry, 7. That's an A, correct? So a complement is everything I didn't check off, which would be 4. Did I check off 4 on accident? Yeah, okay, we'll just ignore that. 4 is what, so a complement means everything I didn't check off. So 4, 6, 8, and 9. Everybody good with complement? Okay, B complement means everything that's not in B. So here 2 is, 4 is, 6 is, 8 is. So everything that's not in B would be 1, 3, 5, 7, 9. And so on. So C complement means everything not in C. So C is 4 and 8. So check 8. Oh! Okay, so check off 8, check off 4. So everything that's not would be 1, 2, 3, 5, 6, 7, 9. I'm not going to write that down. You write it down though. 4 and 8. I'm pointing at the 2 that it is. So complement means all the answers that are not that. So put that down while I point for you. Everybody good? Okay. Now 7. Oh, we already just did 7. B united with C. B united with C. So let's unite them. Union. We have a 2, a 4, a 6, and an 8 from B. Now we go on to C. We've already listed 4, and we've already listed 8. So we're good. Don't listen twice. B intersects C. Where do they intersect? Meaning where are they the same? 4 and 8, correct? And then this isn't a C. Notice how it's like a sideways looking weird thing? Literally, I've never seen that until I saw that worksheet. A different teacher made it. What it means is it's asking you, is A a subset of the sample space? So that like weird little like side symbol like that is just saying, is A a subset? So isn't that a smaller piece of the sample space? So we'd say yes. Is B a subset? Well, yeah, it's a smaller piece of the sample space, so we'd say yes. That's all that means. So like, for example, if there was a D and it was heart, comma 1. Do you see how if D was a subset and we had D, is D a subset, we'd say no, because do you see how there's not a heart in the sample space? So that one would be a no. All right, so do the front of that worksheet.